Alright, so this is the review for the unit exam that covers Chapter 8 and Chapter 9. Let's start with Chapter 8. In number 1, we're asked what do we need to check to see if two shapes are similar? Well, the first thing we need to check to see is if all the corresponding angles are congruent. So all the angles that match each other from shape to shape, they need to be congruent or equal. And the next thing we need to check is that all corresponding sides, now all those sides, all those matching sides, don't have to be equal, but they need to be proportional. They need to create the same fraction when we compare them, or they need to have the same scale factor. So let's check if these two shapes are similar. Well, angle A and angle H are equal to each other. Angle C and angle K are equal to each other. And all the other angles are equal to 97. So all the angles are congruent. We have that part checked. The last part we need to check to see if all the corresponding sides are proportional. So these sides that are 4 clearly match up to these sides that are 6. So if I write a proportion or compare them, 6 over 4, that reduces to 3/2. So I need to compare the other sides as well. I'm going to compare the 12 and the 8 and make sure I get the same fraction. If I get the same fraction, then the shapes are similar. Sorry, the sides are proportional, making the shapes similar. If they're not the same fraction, then the shapes are not similar. 12 over 8 I can reduce by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So yes, both of these will have the sides are proportional. So yes, the shapes are similar. So to write a similarity statement, that means shape A, B, C, D is similar. So H matches up with A, so H, J, K, L. And the similarity ratio is 3 over 2. For number 2, what are the 3 theorems you can prove that triangles are similar? Well, there is side similarity. If you have 3 pairs of sides proportional, then the triangles are similar. There's side angle side similarity. If you have 2 pairs of sides and the angle in between congruent, the 2 pairs of sides proportional, the angle between is congruent, then the triangles are similar. Or if you have 2 pairs of angles congruent, that's AA similarity. So you have to decide if these triangles are similar or not. So here we have a pair of overlapping triangles that we should separate. That's 2 and 3 for the small triangle. And for the large triangle, this distance is 6, 4 plus 2, and this distance is 9. Both triangles have as its vertex angle J. So angle J at the top, those are equal. So we need to see if these sides are proportional. So if 6 over 2, that's 3, is the same as 9 over 3, which is also 3. Okay. So the 2 sides are proportional and the angle is in between. So these triangles are proportional or similar by side, angle, side. For part B, I don't have any numbers, but I know that this angle right here is equal to that angle right there because those are vertical angles. These arrows mean these lines are parallel. So when I have parallel lines, I should be able to find maybe alternate interior angles. So angle T is congruent to angle S because they are alternate interior angles, and alternate interior angles are congruent when lines are parallel. So I have 2 pairs of angles. Angle similarity. For part C, this side is equal to this side is equal to that side, and PR is congruent to PR because of the reflexive property. So, in fact, these triangles are similar, but even more so, they are actually congruent. They're actually equal to each other. So these triangles are similar because of SSS. They all have the same ratio, and the ratio is 1. Because that's the same, and that's the same. D looks like side, side, side similarity because they have all three sides. But let's check that and make exactly sure. Let's check with 20. And that's the largest side on this one. It should match up with the largest side on this one. And that's 10. 20 over 10 reduces to 2. Let's see if we get the same fraction all the time. Let's pick 14. That's the smallest number. And 6 is the smallest number. 14 over 6 only reduces to 7 over 3, which doesn't equal 2. So actually, these triangles are not similar. So it is not side, side, side. These are not similar. For number 3, we're going to use the picture to complete the proportions. All those lines are parallel, so they will create proportional parts. We just need to find their matches. So JD, this length, over DE should be proportional to, should be equal to JF. And so I need this part. Can that matches up? So I need FE. Part B, CF, there, and CI, BE, that should be BH down there. So we're just finding the corresponding parts and matching them up and making a proportion out of them. JA plus AG, so that's this length and this length, over AG, should be something BH. So that's JB plus BH. JF plus FI over JF is equal to JD plus DG over JD. So in 4, we have to solve for x, and that's when we need to set up our proportions. So this is where the angle gets bisected in this triangle. You're creating proportional parts, so I can go 6 over x is equal to 9 over 8. You can set this up a bunch of different ways. You could have gone 6 over 9 equals x over 8. You could have done all sorts of things. As long as you basically don't go across with parts that don't match up. Like I can't go over 6 over 8 and 9 over x. That just doesn't work. There's no logic to it. So cross multiply to solve. 9 times x is 9x. 8 times 6 is 48. 48 divided by 9 is 5.3 repeating. So because these lines are parallel, I can use the side splitter theorem in saying that x with x plus 1 is equal to 6 over 9. If I cross multiply, 9 times x is 9x, and this is 6 times x plus 1. So 9x equals 6x plus 6. I subtract 6x. So 3x is equal to 6, and therefore x should equal 2. On the back are some word problems. So Joan places a mirror 24 feet, here's the mirror, from the base of a tree. So here's a tree. And the mirror is 24 feet from the tree. She stands 3 feet from the mirror on this other side. And she can look up and see to the top of the tree. Her eyes are 5 feet above the ground. And we need to find how tall the tree is. X. Okay, so now we need to create a proportion to solve this problem. So I can go with 5 over the height of the girl with the height of the tree. 5 over x. That should equal the distance from the girl to the mirror, 3, with the distance of the tree from the mirror, 24. So when I cross multiply, I get 3x. 5 times 24 is 120. And divide by 3, and I get that x is 40 feet tall. The height of the tree is 40 feet. And number 6, a 6-foot man casts a shadow that's 18 feet long, and a tree nearby casts a shadow that's 93 feet long. So again, I'm going to set a proportion. They form similar triangles. So I'm just create a proportion. I need to find how tall the tree is. X. So 6 goes with x, 18 with 93. 18x, 6 times 93 is 558. Divide by 18 is 31. So the tree is 31 feet tall. Okay. Number 7 is a proof of the side splitter theorem, saying if you're given a triangle and these are parallel, that this part is proportional to this part. Or XR over RQ is proportional to SQ over YS. Or whatever. So the first statement is RS is parallel to XY. That is given to us. The second statement says that angle 1 is equal to angle 3. These angles are equal. And that also angle 2 is equal to angle 4. Why? The reason? Well, since we have parallel lines and they form these corresponding angles. So if lines are parallel, then the corresponding angles are congruent or equal. And since we have two pairs of angles being congruent, the triangle is similar by angle-angle similarity. So because the triangles are similar, this part, XQ, from the big triangle, should match up with RQ from the small one. That should be proportional. It should be the same fraction as if I go with YQ to SQ, because those are the matching parts of the similar triangles. So that's just like from the definition of similar. You have proportional sides. So the next statement says XQ is the same as if you went with X to R and R to Q. Same thing with Y to Q. You could have gone Y to S plus S to Q. And that's the segment addition postulate. After that, notice how there's an XQ here and an XQ there. They took all of this and replaced XQ with it. So that's why there's a XR plus RQ on the top. So they use substitution. And lastly, in 7, they split this into two parts, two fractions, to XR over RQ and RQ over RQ. Those RQs reduced to 1. Same thing with SQ. Subtracting 1 from both sides gets you this result. And we're just going to go with simplify. So number 8, I have to decide if this is triangles acute, obtuse, or a right triangle. So we're going to use Pythagorean theorem to do that. Well, if it's going to be a right triangle, then a squared plus b squared has to equal c squared. That's how I know it's a right triangle. For it to be obtuse, I know that a squared plus b squared, I know the c squared side has to be bigger to be obtuse. And for acute, a squared plus b squared, I know the c squared side has to be smaller. So the c is always the longest side, and clearly I think the square root of 57 is the longest side, because the square root of 57 is about 7.5, which is longer than 7. So that's our c. So we're just going to compare. 3 squared, 7 squared, and the square root of 57 squared. 3 squared is 9, 7 squared is 49. Square root of 57 squared is just 57 back. The square and the square root can cancel each other out. 9 and 49 is 58. So the c squared side is smaller. And if the c squared side is smaller, then this triangle is acute. In number 9, I have, this is actually from chapter 9, but I have 3 right triangles. I have a right triangle, a big one, and it got split, so creating 3 similar right triangles. So I'm going to refer to this as triangle 1 and 2, and the big one as 3. In the first triangle, in triangle 1, I can write a proportion. I can write x over 9, comparing the hypotenuse over the shorter length of the shorter leg. So I'm comparing the hypotenuse with the short leg. I need to look in another triangle that has a hypotenuse and a short leg to compare it with. So let's look at triangle 2. Here's the hypotenuse of triangle 2. I don't have any numbers there. And here's the short leg for triangle number 2. I don't have anything there. So that's not helpful. Let's look at the big triangle. The hypotenuse on the big triangle is 25. So let's start with that. The short leg on the big triangle is this x. So there I have something, and now I have a proportion to use. X times x is x squared. 9 times 25 is 225. And square rooting to solve for x, I get that x is 15. In number 10, same deal. Triangle 1, triangle 2. So in triangle 1, I have 9 and 12 in the same triangle. 9 is the shorter leg, obviously, and 12 is the longer one, because 12 is longer than 9. Let's look at triangle 2, because in the big triangle, there's no short leg or long leg, so I need to just work exclusively with triangle 2. In triangle 2, the long leg is 12, so actually the short leg is 12. This is shorter than this part. And the long leg is this, but I don't know how much that is. This is called x. But this part, I can say that that's x minus that 9. And I can solve this proportion. Help me solve for x. Cross multiply. 12 times 12 is 144. 9 times x minus 9 is 9x minus 81 when you distribute. Taking 144 and adding 81. So that's 225 equals 9x. Dividing by 9, I get that x is 25. And number 11, let's solve for x again. So that's triangle 1. I will go 60 over 36, because that's the hypotenuse over the short leg. And let's look at the big triangle. The big triangle has a hypotenuse and a short leg. The hypotenuse in the big triangle is this whole length. So it's not just x, but x plus this 36. And the short leg is on the bottom of the big triangle, and that's 60. So 60 and 60 is 3600. This 36 times x is 36x. Distributing 36 times 36 is 1296. Subtracting 1296 from both sides, I get 2304 equals 36x. Dividing by 36, I get x equals 64. Okay, so the chapter 9 review, I have to use sine, cosine, or tangent to solve for the indicated measure here. So in 1a, I need to find PQ, so I'll call that my x. So to decide which one to use, sine, cosine, or tangent, I always go to the angle first. and then I'll label the triangle accordingly. So let's start with x. Is x the opposite leg from the 19 degrees, the adjacent leg, or the hypotenuse? Well, that's all the way across the triangle, so that's the opposite leg. And the 11, is that the adjacent leg, the one right next to it, or the hypotenuse? That's where confusion comes in, because 11 is right next to the 19 degrees, but it's not the adjacent leg, because it's not a leg. It doesn't form the 90 degrees. It's actually the hypotenuse, because it's across from the 90 degrees. So then we use, famously, SOHCAHTOA to help us figure out which one to use. So the only letter combination of 3 letters that has opposite and hypotenuse is SO. Therefore, we use sine. So the sine of 19 degrees equals the opposite, x, over the hypotenuse, 11. To solve this, we cross multiply. 1 times x is x, 11 times sine 19. We'll use that in our calculator. 11 times sine 19 degrees is 3.6, rounded to the nearest tenth. Part B, I need to find KL, which is this one. So again, here's my angle. 9.5 is all the way across from the 61. That's opposite. X is right next to it, and it is a leg, so that's adjacent. And I look back up to SOHCAHTOA. Opposite and adjacent is tangent. So the tangent, 61, equals 9.5 over x. I cross multiply to solve this. 1 times 9.5 is 9.5. X times tangent, 61. Now I can't type this on the calculator yet because I don't have x by itself. To get x by itself, I need to divide both sides by tangent 61. So x equals 9.5 divided by tangent 61. 9.5 divided by tangent 61. That's 5.3. In part C, I need to find xz, which is this one. Here's my 25 degrees. 33 is right next to my 25 degrees, and it's a leg, so that's the adjacent. X is across from the 90 degrees, so that's the hypotenuse. Adjacent and hypotenuse mean cosine. So the cosine, 25, equals adjacent, which is 33 over x. Again, cross multiply to solve. 1 times 33 is 33. X times cosine, 25. Divide both sides by cosine 25. So x equals 33 divided by cosine 25. And that's 36.4. And number 2, what functions must be used to solve missing angles in a right triangle? Well, we have to use the inverse functions, the inverse sine, the inverse cosine, and the inverse tangent. So if this is our angle, x, we always start at the angle. 17 is opposite, and 7 is adjacent. So we're opposite and adjacent, we use tangent. So the tangent of x is 17 over 7. And to solve for an angle, a missing angle in a right triangle, we need to use the inverse function, the inverse tangent of 17 over 7. That'll tell me what angle has a tangent that's 17 over 7. So inverse tangent, 17 divided by 7, closing the parentheses. So on angles, usually the convention is to round to the nearest whole number, whole degree. So 67.6 rounds to about 68 degrees. Part B, is not solving for an angle. It's misplaced. So here's 65 degrees. Across from the 65 is 10, so that's opposite. X is the hypotenuse. So I'm going to use sine. Sine 65 is 10 over x. Cross multiply to solve. 1 times 10 is 10. X times sine 65. Divide by sine 65 to solve for x. So x is equal to 10 divided by sine 65. And that's 11.0. Part C. There's my angle. 16 is adjacent, it's right next to my x, and 20 is the hypotenuse across from the 90 degrees. So I use cosine. So the cosine of x equals 16 over 20. So again, I'm solving for a missing angle. I need to use the inverse function. I need to use the inverse cosine of 16 over 20. Again, normal convention is to get round to the nearest whole number on angles, so that's close to 37 degrees. In number 3, I'm given that the sine of 30 degrees is the square root of 3 over 2. Alright, so let's do this. Here's 30 degrees. The sine, the opposite over the hypotenuse of the triangle is square root of 3 over 2. So the opposite side should be the square root of 3, and the hypotenuse is 2. So clearly this triangle is not drawn to scale. The cosine of what angle is also 3 over 2, or square root of 3 over 2? Well, if I get that this is 60 degrees, right? Because 30 plus 90 is 120, minus from 180, that's 60 degrees. If I enabled the cosine is adjacent over hypotenuse. Well, the cosine of 60 degrees, here's the adjacent, and there's the hypotenuse, 3 over 2. So the cosine of 60 degrees has a result of the square root of 3 over 2. So that's what they needed. They needed 60 degrees. So number 4, a forest ranger in a tower is a 120-foot tower, sees a fire on the ground. The angle of elevation from the fire, not the fur, to the ranger is 35 degrees. What is the horizontal distance between the tower and the fire? It's x. So here's the angle, this is opposite, this x is adjacent, so tangent, 35, 120 over x. Cross multiply to solve, so 1 times 120 is 120. X times tangent 35. Divide both sides by tangent 35 to solve for x. So x is whatever 120 divided by tangent 35 is. That's 171.4 feet. On 5, a 12-foot ladder is placed against the building. So here's a building, here's the ladder. The ladder is 12 feet. What angle of elevation? Here's the angle there, needs to be formed so the ladder reaches 10 feet, a height of 10 feet. So I need that angle x. So this is opposite, and this is hypotenuse. So I need sine. The sine of x should be 10 over 12. So to solve for a missing angle, I need to use the inverse sine of 10 over 12. And that's about 56 degrees. Okay. So number 6 involves using these rules. I need to solve for this y in terms of x. So this is a 30, 60, or 90 right triangle. So remember the rules for the 30, 60, 90 right triangle. The hypotenuse is 2 times the short leg, and the long leg is the short times the square root of 3. So here's the short leg, the x. You can see that the hypotenuse is 2 times the short leg, 2 times x. Here's the long leg. The long leg is y. I need to take whatever the short leg is, x, and I multiply it by the square root of 3. So I solve for y. I have y in terms of x. That's for the 30, 60, 90. Here's a 45, 45, 90. And so the rule for that is the hypotenuse is the leg times the square root of 2. In our case, the hypotenuse is y. Our leg is x times the square root of 2. So on the back, number 7. We're going to use what we just did, these special right triangles, to complete this chart. This is a 45, 45, 90 right triangle. That means it's isosceles. So if this side is 1, this side is also 1. And we just saw that the hypotenuse should be the square root of 2. This is a 30, 60, 90. If this side is 1, the hypotenuse is twice as long. And the long leg is the same short leg times the square root of 3. So let's fill out this chart without using a calculator. And we want to leave it as fractions. We don't want any decimals. And we want simplest radical form. So the sine of 30 degrees, here's 30. Sine is opposite over hypotenuse. So opposite, 1 over hypotenuse, 2. 1 over 2. Cosine of 30 degrees, adjacent over hypotenuse. So adjacent is square root of 3. Hypotenuse is 2. Tangent of 30 degrees is opposite over adjacent. So opposite is 1. Adjacent is the square root of 3. Now we should remember from algebra that this is not okay. We can't have a radical at the bottom of our denominator. So to take care of that, we multiply the top and bottom by the square root of 3, just to get it in a different form. 1 times the square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9, which is just regular 3 back. So this is the preferred simplest radical form version of the the tangent of 30 degrees. The sine of 45 degrees, we can use this 45, opposite over hypotenuse, 1 over the square root of 2. Again, we aren't allowed to leave square roots at the bottom, so we're going to multiply that fraction by the square root of 2 over the square root of 2. On top, it's square root of 2. On the bottom, square root of 2 times square root of 2 is just 2. The cosine of 45 degrees is adjacent over hypotenuse. So the same exact thing, so I'll just write that square root of 2 over square root of 2. The tangent of 45 degrees is opposite over adjacent, so the tangent of 45 degrees is just 1. 1 over 1. The sine of 60 degrees, adjacent. Sorry, sine is opposite over hypotenuse. So opposite over hypotenuse, square root 3 over 2. The cosine of 60 degrees is adjacent over hypotenuse, so 1 over 2. The tangent of 60 degrees is opposite over adjacent, so the square root of 3 over 1, which is just the square root of 3. What is the law of sines? Well, the law of sines says if you don't have a right triangle, you can take the sine of an angle A over the side across from that angle, and it should equal the sine of a different angle B over the side across from that lowercase angle, or that angle B. The law of cosine says that if you have the side that's opposite of an angle, so lowercase a, that's equal to the other two sides, b squared and c squared, minus 2 times b times c, and then cosine of that original angle. So we use these for sides and angles that aren't in a right triangle, that we can solve for them. We use the law of cosines when it's SSS or SAS. In all other cases, we use the law of sines. So here's a side, here's an angle, here's a side. I'm going to use the law of cosines there. I need to solve for QS. I'm going to call this my capital A, so that I can just substitute in here. So the lowercase a is across from it, so x squared. B and C are just the other two sides. It doesn't matter the order or which you put them in. You can call whichever one you want B or C. Times 6 times 10.5 times cosine 39 degrees. Okay. There are no variables here stopping us from typing that whole thing in our calculator. So let's just do that. 6 squared plus 10.5 squared minus 2 times 6 times 10.5 times cosine 39. All that equals 48.3. So to get just x, I need to square root both sides. So I'll square root my answer. And you get 6.95, or round it to the nearest tenth to 5, makes the 9 round up, makes that round up to 7.0. Part B, I need to find this angle A here. I need to find that. So I don't have side, 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 and I don't have side, angle, side. The angle is not between the two sides, so I'm going to have to use the law of sines. Number for B. So I'll start with the sine of 118 degrees and the over the side across from it equals the sine of x over the side that's across from it. Right. So since I'm solving for an angle, I need to use an inverse function, but I can't do an inverse sine yet for this until I get rid of the 14, so I'll multiply both sides by 14. So that's gone. So to solve this for this x, I need to use the inverse sine, reverse that. Okay, then I need to type all that in the calculator. 14 sine 118 over 20. Inverse sine, 14 times sine of 118, close the parentheses, divide by 20. And that gets me about 38 degrees. For C, I don't have side, side, side. I don't have side, angle, side, so I'm going to use the law of sines again. Mn is what I'm trying to find. Start with the sine of 23 degrees. The side that's opposite is 16. Should equal the sine of 130 over the side opposite is x. Cross multiply to solve this. X times sine 23 should equal 16 times sine 130. Divide both sides by sine 23. So x equals 16 times sine 130 divided by sine 23. Let me do that again. 16 times sine 130 divided by sine 23 is 31.4. And lastly, this is side, 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 so I'm going to use the law of cosines and solve for that missing angle there. So I'm going to start with 10 squared. And that should equal the other two sides, 6 squared and 12 squared, minus 2 times 6 times 12 cosine that angle A, or Q in this case. Can't type all this in the calculator, so I need to clean up what I can. So 10 squared is 100, 6 squared plus 12 squared is 180. 2 times 6 times 12 is 144 cosine A. These are not like terms, so don't do 180 minus 144. They're not like terms because of the times cosine here. So I'll subtract 180 from both sides. I get negative 80 equals negative 144 cosine of A. I'll divide by negative 144. 80 divided by negative 144 is 0.5 repeating. And finally, just to get A, I need to do the inverse cosine of 0.5 repeating. So inverse cosine, and that's 56 degrees.